Hi, good morning, good afternoon, good evening. My name is Javier Perez. I'm open source program manager for IBM in the IBM Z organization. And I'm delighted to be here in this AI Applications Virtual Summit. I'm going to talk to you about the growth of AI open source software in unexpected platforms. So without further ado, let's start for the next few minutes to talk about AI, open source, and platforms. What you are going to see over the next couple of days, we are going to talk about innovations. We're going to talk about AI applications and industry use cases. Specifically in this session, I'm going to talk to you about open source and what it means and how everything pretty much related to AI, uh, machine learning, deep learning relates to open source software. When we talk about use cases, and there are so many, and again, we're going to be hearing more in the next few hours and in the next couple of days about the different use cases that you and your organization, especially if you are in the financial industry, you are taking advantage of AI, machine learning, deep learning. But as a few areas uh, that it's important to highlight, right? Repetitive processes, those are ideal use cases for AI. Cognitive services, also ideal for AI innovation. Cybersecurity is not that well known, but within cybersecurity, there's AI now to blocked to defend against attacks. And at the same time, there's machine learning and deep learning algorithms to identify vulnerabilities, especially in the open source software, in the open repositories that are out there, and you can identify vulnerabilities taking advantage of these technologies. Of course, there are many use cases around finance, insurance, marketing, automation, analysis of big data with analytics. There are so many use cases. The point that I want to make here is all of these use cases, the use of the AI technology, it's all about open source software. So when we talk about open source software, we talk about the latest innovations are being developed in the open. You can see on the images there from augmented reality to virtual reality to autonomous cars, autonomous vehicles. All these latest innovations are right there. You can go to a Git repo and read the code of what's happening, how they are doing all these new technologies. And AI, machine learning, deep learning, is no different. In fact, most of that innovation it's completely out there on the open, even with large organizations like the organization that I represent, IBM, contributing heavily on these technologies. Very much everything is out there in the developing the open. Not to mention that all programming languages and all those frameworks are open source. They're not hundreds, they are not thousands, there are actually millions of open source libraries out there that you as a developer or your developers are taking and building as a building blocks to innovate and build on top of all of that. So the beauty about open source is that it's there, that people can contribute and participate and enhance and continue to innovate and continue to create new technologies, taking advantage of the open environment. So here's an eye test for you. This was put together by FirstMark. They are working on a new one for 2020, and this is the landscape that they identified for big data and AI. Of course, there's so many, right? And there are probably more there. So let me just highlight a couple, right? And let me just focus on open source. And this is just a sample. These are not all the open source software out there that relates to open source, right? This is just a small sample, but you can tell how big is the landscape, how big is the ecosystem of open source software that now all of you or many of you and your organizations are using to build machine learning models, to build applications using AI applications using many of these open source software, some of them more recognizable than others. So I'm going to tell you a little secret there. I want us to see, especially in the financial institutions, and especially in the largest financial institutions, I wanted to know, what open source software are using. So the little secret, and anyone can do it, is I went to look for job postings. Job postings where all these large financial institutions are looking for junior engineers or developers or senior developers or architects, and the skills that they're looking for, well, they list the technologies, right? So I actually got a list of 7 8 very large financial institutions, global financial institutions, and I had a list of the open source software that they are looking, the skills that they're looking to hire for that list of open source software. So I have multiple lists now, and what you see here on the screen is the most known or the most common request for technologies on those job postings. Of course, Python, Tensorflow, and a few others that you see there. And regardless of the architecture, everyone kind of defines their own AI architecture. This seems to be the most common open source software in the financial industry when we talk about AI, right? They're all open source. And when I'm talking about open source, of course, I have to talk about Linux, right? Linux, it's close to, in 2021, it's going to be 30 years of Linux. Of course, before that, there was Unix, and it continues to innovate, right? It's a clear example of a successful open source project that you built a large community of contributors, and people continue to contribute on a daily basis with a large community, and that's how you keep improving. That's how you keep fixing bugs, addressing vulnerabilities, and innovating within an open source project, a well-managed project with committers, with maintainers. It's just a great example what it's a Linux. And the nice thing about Linux is it runs everywhere, right? You have it on a base for your Android phones, or you have it on any type of platform there. You can see on the screen there's an Arduino card. The same goes for a Raspberry Pi. In those cases, those are ARM or ARM64 processor architectures, but they use Linux. And the only difference is that the Linux had to be compiled on the corresponding processor architecture. So obviously very common, the use of x86 processors or Power, or there are a few Spark processors out there. I believe Oracle stopped selling them in 2017. So there's still a few Spark out there. And the one I want to get your attention to is the S390X processor architecture. That's what it's known for, the architecture for mainframes. Who, just like any of all the other processor architectures, they use Linux, they run on Linux, and all you have to have is this Linux distribution compiled on the corresponding platform. So with S390X, you have Linux running on mainframes. And this image is probably what most of you have as a perception of a mainframe, right? And I include myself. As a personal story, I went to university in the 90s, in the early 90s, computer science. And back then, mainframes were considered old, right? This picture is from the late 1950s, early 1960s. And, I was studying computer science in the early 90s, and, they didn't teach me COBOL or Fortran. They were considered old technologies. But let me tell you one thing. Still today, some of the most important mission-critical applications are running on mainframes. Of course, the mainframes don't look like that anymore. But when we talk about all the financial institutions have a mainframe. Credit card transactions, billing systems, reservation systems, payrolls, all still today run on mainframes. And the mainframes have been evolved. They don't look like that. In fact, they look like this today. And we don't call them mainframes anymore. This happens to be an IBM Z. This is what is a modern or what is today a mainframe. And you can have, this is a one frame, you can have a 2 or 3 or 4, you can scale this, but this beauty is what it is today a mainframe, right? So nothing to do with that old perception that most people have. And you have two versions. You have what is called IBM Z, where you can have you can collocate Linux and the traditional mainframe operating system, ZOS. You can collocate ZOS and you can collocate Linux. Or you can have another model, which is called Linux One, which is only for Linux, so optimized only for Linux. I'm not here to sell you these platforms, but I wanted to highlight a few key points that I believe they are just amazing. First of all, you can execute up to 1 trillion web transactions per day here. Let me repeat that, 1 trillion HTTPS transactions per day in one of these platforms. You can have up to 2.4 million Docker containers, maybe you're very small containers, but you can have that many containers in a box like that. And the feature or the statistic that amazed me the most is compression time. You can compress up to 275 gigabytes of data per second. 275 gigabytes per second, or over 12 million transactions per day in terms of compression. These are just amazing numbers, and you can read through the bullet points. These are just amazing numbers that you will have to pay a lot of money if you want to do this on a public cloud. You can do this in one of these platforms. And when I talk about Linux, and still people think, well, it's COBOL, it's some old technology. Most of the, at least more than 50% of the mainframe installations are running Linux. And in fact, these are numbers from IBM, more than 90% of the largest enterprises are running Linux on the mainframe. And that's across all distributions, by the way. All the Linux distributions, like from Red Hat to SUSE to Ubuntu and more, are available on IBM Z or Linux One. And this is an example of another chart to show you some of the recognizable open source software that has been ported, that it works, and it's been validated that works on these IBM Z and Linux One platforms. This is just a partial list, but it's a growing list. And actually not only on Linux, but also on the ZOS operating system. So we're talking about modern but high capacity, high performant platforms. And that just makes sense, having this architecture and these features to make it ideal for AI applications. You need high performance. You need for the best I/O intensive transactions, which is what you need for many of the AI use cases. Well, with a platform like this, you get it, right? Including for structured or unstructured data. And many of you know, and I don't have to tell you, but sometimes 70-80% of your work is just to managing, fixing, getting the data ready, so then you can run your machine learning models, right? So most of the time, sometimes it's or many times it's spent on just addressing the data. So the more I/O intensive, the more speed you get to help you with that, the better, right? So high performance, also access to storage and databases. That's key, right? When you're talking about not a few thousand transactions, but millions of transactions, gigabytes or millions of transactions, you want high performance use of your storage and your databases, and that's what you get with this platform. And with that, you get the best performing machine learning models, right? And just to show you, just to mention a couple of examples, that's some of the numbers that we've seen. And a use case for a credit card fraud detection, it was doing the detection at the speed of 10 milliseconds. Up to 10 milliseconds at that speed to be able to detect a fraud. And again, we're talking about many transactions, right? And the same goes for a use case where an AI application that does price prediction and based on the values, based on the market, be able to predict pricing, you can get up speeds of up to 100 milliseconds per transaction, which is incredible. And when we talk about the speed, it's also speed of the business, right? And if you have your mission critical applications, like the ones that I was mentioning earlier, in terms of payroll or billing or any other financial transaction, well, if you already have that on a mainframe, on IBM Z or Linux One, well, you can integrate that tightly also with your AI applications, as opposed to go and send that to a public cloud or some other servers. So you can tightly integrate that within the same place and keeping all the security and workloads isolations and all the different features that you get with a mainframe. Best-in-class security with encryption everywhere, at rest, in transit. That's one of the big features about this platform. And of course, with a growing ecosystem of open source software, there's no limit, right? You just like using any other platform, you have the open source software available to build your AI applications in this platform. So as a key takeaways, I think you get this, right? It's all about open source. This is something that I just want to kind of emphasize. It's really all about Linux. And while you can use any platform or cloud service, IBM Z and Linux One are ideal for enterprise AI use cases. And finally, well, I'll invite you to contribute, not just downstream and use open source software, but also to contribute back what is called upstream with your innovation, with your bug fixes, with your vulnerability fixes. So with that, I think we have time for Q&A. You have my contact information, and thank you very much.